So, hi everyone, welcome to Engineering Basics. So, this is the first video of this playlist, which is the Chemical Reaction Engineering playlist. And for this playlist, I will just give a brief overview on the concepts of chemical reaction engineering. This playlist is more focused on answering chemical reaction engineering related problems. So let's begin. So what is chemical reaction engineering? So CRE, understanding how chemical reactors work, lies at the heart of almost every chemical processing operation. So first we have the raw material, and then the separation process, and then there's a chemical process, and then another separation process, and then you have the products or byproducts. So reactor design uses information, knowledge, and experience from a variety of areas: thermodynamics, chemical kinetics, fluid mechanics, heat and mass transfer, and economics. So CRE is a synthesis of all these factors with the aim of properly designing and understanding the chemical reactor. So for the reactor design, we consider two things. So we have the reaction and the reactor. So for the reaction, we have the stoichiometry, single versus multiple reactions, and then kinetics, the elementary versus non-elementary. Then for the reactor, we have isothermal reactors versus non-isothermal reactors. And then we also have the ideal versus non-ideal reactors. And then steady state versus non-steady state. I will be giving a more detailed discussion on these in the following videos. So moving on. So in CRE, we have four different types of reactors. So first, we have the well-mixed batch reactor. Then second, we have the continuously stirred tank reactor, or CSTR. And then third, we have the plug flow reactor, PFR. And then fourth, we have the packed bed reactor, or PBR. So as you can see in this figure, okay, now we're going to talk about the basic molar balance. So these reactors, we will be having a more detailed discussion on this in this playlist, okay, in the following videos. So since we're going to be talking a lot about chemical reactions, so just a reminder or a important note that the rate of reaction means how fast a number of moles of one chemical species are being consumed to form another chemical species. So going back again in this figure for the basic molar balance, as you can see, we have here the system volume, and then we have the rate of flow of J in to this system right here, and then we have the rate of flow of J out of the system. And so Gj is actually the rate of generation of J by chemical reaction minus the rate of decomposition of J. So it can be, so this figure reflects this equation. So we have Fj right here, the rate of flow of J into the system, minus Fj the rate of flow of J out of the system plus Gj equals dNj over dt. So these are the units right here. So dNj over dt is the rate of accumulation. So Nj is actually the moles of J, most J in system. So dNj over dt is the most J in system at time t. So now, again, you should just always remember that for the basic molar balance, you should always start with in minus out. So in, okay, this is the rate of flow J in to the system right here, minus out, which is right here, Fj, plus the generation, which is Gj, okay, generation right here, equals to the accumulation, which is dNj over dt. So now, coming from this equation, we must remember that if the system is uniform throughout its entire volume, then Gj is equals to Rjv. So Rj is moles generated per unit time and volume, while V is volume. And then for Gj, it is the moles J generated per unit time. Okay, so with this equation, for the basic molar balance equations. So again, if you remember, we have in minus out. So in is here, minus out, which is here, plus generation, which is Gj, equals accumulation, which is the rate of accumulation, which is the most J in system at time t. So now, remembering this equation, Gj equals to Rjv, for a uniform rate in V, so from this equation right here, Gj is now Rjv. Now this is the equation for a uniform rate in V. And for a non-uniform rate in V, we have this equation. Okay. So as you can notice that we have to integrate for this equation. Now, why do we have to do that? So remember, if you can recall in your previous chemical or chemistry classes, the uniform rate means that the rate of reaction in here, okay, is constant throughout the entire volume of the reactor. So the reaction rate per unit volume, okay, is the same at every point within the reactor. While for this non-uniform rate in V, we have to integrate because the rate of reaction varies at different locations within the reactor volume. So the reaction rate here, it changes. It changes depending on the position within the reactor. So for this is the end of this video. Please stay tuned for upcoming videos about chemical reaction engineering, and we will be having a more detailed discussion on the types of reactors. And then we will be uploading more uh, problems, how to answer problems for CRE.